Hello everyone, welcome to Neso Academy. We are learning theory of computation, and in the previous lecture, we have understood how to convert an epsilon NFA into its equivalent NFA with the help of an example. And now in this lecture, that is epsilon NFA to NFA conversion solved problem, we are going to solve an important problem for conversion of epsilon NFA to its equivalent NFA. So the topic for this lecture is epsilon NFA to NFA conversion. Let's start with our problem statement. Convert the given epsilon NFA into NFA. So here you can see you are given with an epsilon NFA and you need to convert this epsilon NFA into its equivalent NFA. I hope you remember all the steps for this conversion. In the step number 1, we need to find the epsilon closure of all the states of this epsilon NFA. In step number 2, we need to find all the new transitions for our resulting NFA. In the step number 3, we need to update the final states, and in step number 4, we need to construct the transition table and transition diagram of our resulting NFA. So let's start with the step number 1. Step number 1. Find epsilon closures of every state of the given epsilon NFA. So in the first step, we have to find the epsilon closures of all the states of this epsilon NFA. Now what is epsilon closure? I have explained you that the epsilon closure of a state contains all the states that are reachable from that state using only epsilon transitions, including the state itself. So if I have to find the epsilon closure of the state A, I need to check what are the states that I can reach from the state A using only epsilon transitions. Here you can see from the state A, I can reach the state B using only epsilon transitions. I can also reach the state C using only epsilon transitions. So both B and C will be the part of epsilon closure of A. And as per the definition, epsilon closure of A will also contain the state A itself. So, the epsilon closure of A is equal to A, B, C. Similarly, we need to calculate the epsilon closure of B. Now, as you can see, we can reach the state C from the state B using only epsilon transition. That is why C will be the part of epsilon closure of B. And as per the definition, B will also be the part of its epsilon closure. So, epsilon closure of B will be equal to B, C. Now let's talk about the state C. The state C cannot reach any other state using epsilon transition. That is why the epsilon closure of the C will only contain the state C itself. In this way, we are done with the step number 1, that is, we have calculated the epsilon closures of all the states of this epsilon NFA. Now let's proceed with the step number 2. Step number 2. Construct the new transitions using epsilon closures. That means, in the step number 2, we need to find the new transitions for our resulting NFA using the epsilon closures that we have just calculated. So these are the epsilon closures of the state A, B and C that we have just calculated in our step number 1. Now we need to construct the new transitions for our resulting NFA. This is the epsilon NFA, and now we need to calculate the new transitions. So if you remember, I have given you an important formula for finding the new transitions of our NFA. This is the formula that I have given to you. And now, we need to simply apply this formula to find all the new transitions. Here, Q will be replaced by the state for which we are finding the new transition, and A will be replaced by the input symbol for which we are finding the new transition. As you can see, in this epsilon NFA, there are total 3 states, and there are total 3 input symbols. That is why the total number of transitions for our resulting NFA will be equal to 9. we need to find the transition for the state A for the input symbol A, B and C, for the state B for input symbol A, B and C, for the state C for input symbol A, B and C. So there will be total 9 transitions. Let's find the transition number 1, that is delta dash A comma A. This is the formula, and we have replaced the state Q with the state A because right now we are finding the transition for the state A on the input symbol A. Now this epsilon closure of A will be replaced by A comma B comma C like this, and delta A comma B comma C on getting input symbol A can be expanded as delta A comma A union delta B comma A union delta C comma A. And now we can simply calculate all these transitions using this diagram. Delta A comma A. So A on getting input symbol A, the next state is also A. So this will be replaced by A. Now B on A. So as you can see, B does not have any transition for input symbol A. So this will be replaced by phi. Delta C comma A. C also does not have any transition for input symbol A. That is why this will also be replaced by phi. So finally we will get A union phi union phi. And on taking the union, we will get only A. The epsilon closure of A is A comma B comma C. So finally, delta dash A comma A will be equal to A comma B comma C. In this way, we have calculated the new transition for the state A on getting input symbol A. Now we will find delta dash A comma B. Again, epsilon closure of A will be replaced by A comma B comma C, and this can be expanded as delta A comma B union delta B comma B union delta C comma B. And let's calculate A comma B, B comma B and C comma B. So A does not have any transition for input symbol B. For the state B, on getting input symbol B, the resulting state is also B. So this will be replaced by B. And C on getting input symbol B, also there is no transition. So we will get phi union B union phi. And on taking the union, we will get B. The epsilon closure of B is B comma C. That is why delta dash A comma B will be equal to B comma C. In this way, we have calculated the transition for the state A on getting input symbol B. Now, we will find delta dash A comma C, which is our last input symbol for the state A. Again, we have to replace the epsilon closure of A by A comma B comma C. And now we can expand this as delta A comma C union delta B comma C union delta C comma C. Now you can simply see in this diagram that A and B does not have any transition for input symbol C. That is why both of these transitions will be replaced by phi, and delta C comma C results in the state C itself. So finally we will get phi union C, and this can be written as only C, and the epsilon closure of C is C. So finally we will get delta dash A comma C as C. So we have completely calculated all the transitions for the state A, that is for input symbol A, B and C. Now let's move forward with our next state, that is B. Delta dash B comma A. First we need to replace epsilon closure of B by B comma C. So here we have written B comma C, and now we can simply expand this equation as delta B comma A union delta C comma A. And now delta B comma A. So B does not have any transition for input symbol A, and delta C comma A. C also does not have any transition for input symbol A. So we will get phi union phi. That will result in phi, and epsilon closure of phi will also be equal to phi. So finally we are getting delta dash B comma A is equal to phi. That means in the resulting NFA, we will not have any transition for the state B on input symbol A. So we have calculated total 4 transitions, and in this way, you can find the transitions for B on getting input symbol B, B on getting input symbol C, C on getting A, C on getting B, and C on getting C. In this way, we can find all the 9 transitions, and these are all the 9 transitions that we can calculate using the same procedure. And we are done with our step number 2. That is, we have constructed the new transitions for our resulting NFA. And now we can proceed to our step number 3, which is date the final states. So, I already explained you in the previous lecture that if the epsilon closure of the state contains at least one final state of the epsilon NFA, then that state becomes a final state in the NFA. So, these are the epsilon closures we have calculated, and you can clearly see in this diagram that C is the final state of this epsilon NFA. Let's check. Epsilon closure of A contains C, epsilon closure of B also contains C, and epsilon closure of C also contains C. That means the final state of epsilon NFA, which is C, is contained in the epsilon closure of A, epsilon closure of B, and epsilon closure of C, which means the final states of the resulting NFA will be A, B, and C. That means all the 3 states will be the final states of our resulting NFA. And in this way, we have calculated all the final states and we are done with the step number 3. Let's move to the very simple step, that is the step number 4. Construct the NFA transition table and transition diagram. So we have calculated all the transitions in our step number 2, and now we need to construct the NFA transition table and the NFA transition diagram. Let's first construct the NFA transition table. This is the basic structure of our transition table. A, B, and C are the 3 states, and we know that all the 3 states are final states. A, B, and C are the 3 input symbols, and now we simply need to fill these blank cells. A on A gives A, B, and C. So here we will write A, B, and C. A on B gives us B, C. So here we will write B, C. Similarly, A on C gives C. B on A gives phi. B on B gives B, C. B on C gives C. C on A gives phi. C on B gives phi. And C on C gives C. Now don't get confused because these uppercase letters are the names of the states. That means uppercase A, uppercase B, and uppercase C are the names of states, while the lowercase symbols, that is the lowercase a, lowercase b, and lowercase c are the input symbols. So don't get confused between these two. So we have constructed the transition table of NFA, and now it's very simple to convert this transition table of NFA into the transition diagram of NFA. So we have 3 states, A, B, and C. Here you can see we have 3 states. All 3 are final states. That is why we have represented all these states with the double circle. A is also the initial state of this NFA. Now we simply need to construct all the transitions. A on A gives A, B, and C. So A on the input symbol A gives A, B, and C. A on B gives B and C. So A on B gives B and C. A on C gives only C. So A on C only gives C. B on A gives nothing. B on B gives B and C. So B on B gives B and C. B on C gives C. So B on C gives C. C on A gives nothing. C on B gives nothing. C on C gives C. So we will simply create a self loop for the input symbol C over the state C. In this way, we have constructed the transition diagram of our NFA from the transition table of this NFA. So we are done with the conversion process of epsilon NFA into NFA for this particular problem. And now it is your responsibility to convert the following NFA that we have constructed into its equivalent DFA. You already studied how to convert an NFA into its equivalent DFA using the subset construction algorithm. You need to follow the same steps and you need to convert the NFA into its equivalent DFA. In this way, we are done with our topic Epsilon NFA to NFA conversion. So this was all from my side for this lecture. Thank you and I'll see you in the next lecture.